Hello everyone, welcome to this video lesson. In this video lesson, we are solving a problem from the concept of mechanical properties of solids. Let me read out the problem first. The problem is like this. If the radius of the loaded sphere at the end of a wire is doubled, how does the elongation of that wire is going to be affected? That's what the question is. Let us try understand what the meaning of the question is. There is a rigid support to which one end of the wire is attached. The other end of the wire is having a sphere suspended, who is going to act like a load. What is given about that load is its radius. What happens is actually this sphere must be having some mass, so its weight is going to act in a downward direction, who is going to act like a force acting on the wire, where the wire is having a length L and area of cross section A. As there is a force acting on the wire shall expand, and we are supposed to calculate how much is that expansion is. I can write a basic definition of Young's modulus as a longitudinal stress force by area by longitudinal strain delta L into L. So I can write Young's modulus as F into L by area into delta L. Our aim is to calculate delta L, so I can write a formula FL by AY. I know it is having a certain area of cross section because it's having some radius. Area of cross section is pi r square, who is constant, which is not a variable at all. Wire is the same, so Young's modulus is constant. Area of cross section is constant. Length of the wire also constant. So it is obvious that increase in the length of the wire is directly proportional to the force applied. Who is applying the force? The load of the sphere. That's nothing but equal to mg. But we don't know the mass of that sphere. We don't know. Instead of the mass of the sphere, we know the radius of the sphere. So I would like to write density of that sphere is mass of the sphere by volume of the sphere. As I want the mass of the sphere, I can write it as volume into density. As the sphere material is not changed, only its radius is doubled, density is constant. Spherical in the shape, so volume of the sphere is 4 by 3 pi r cube into density rho. So substituting this value, I can write delta L is directly proportional to, in the place of m, 4 by 3 pi r cube, where r is the radius of the suspended sphere, and density, and of course G. All the other terms are constant here other than the radius of that suspended sphere r cube. So I can write increase in the length when the sphere of radius r is suspended when compared with the increase in the length when the sphere of radius 2 are suspended as r1 by r2 whole cube. R1 is r, R2 is 2r in our given problem, whole cube. So it's nothing but equal to 1 by 8. So delta L1 by delta L2 is 1 by 8. Our increase in the length of the wire in the second case is 8 times increase in the length of the wire in the first case when a sphere radius only r is suspended. That's it. We are solving it basing on the Young's modulus definition itself. Thank you for watching. Keep coming back for more and more video lessons. Thank you.